General problems, number 83. A very light cotton tape is wrapped around the outside surface of a uniform cylinder of mass M and radius R. The free end of the tape is attached to the ceiling. The cylinder is released from rest, and as it descends, it unravels the tape without slipping. The moment of inertia of the cylinder about its center is that. Letter A. On the circle above, show all of the forces applied on the cylinder. We have mg down, and we have a tension force going up. B. Find the acceleration of the center of the cylinder when it moves down. All right, so to get the acceleration, we have to sum up the forces for translational movement. So let's do that first. Translational. And this thing is accelerating downward, right? So we have summation of forces equals negative ma. Tension force up, mg down, negative ma. So the tension force is going to equal mg minus ma. Let's hang on to that for a little bit. And now let's look at rotational. So rotational is we have tau equals negative moment of inertia times angular acceleration. And we also have the torque going in this direction, which is clockwise, which would be negative. So we can eliminate the negatives. And we have tau equals our moment of inertia, which is 1/2 mr squared times angular acceleration. And we need to convert all of this into translational type variables. So we know that acceleration equals r times angular acceleration. So angular acceleration is acceleration over r. So we can plug this in for our angular acceleration. We also know that torque is equal to force, in this case it's a tension force, times the radius. So we can plug this in for our torque. So let's do those substitutions. So we have tension force times r equals 1/2 mr squared times a over r. Well, we see we have r in the denominator. That eliminates the square, and we can divide both sides by r, and that will eliminate the remaining r. So we have tension force equals 1/2 ma. All right, so we have that all in linear fashion. So since this tension force is equal to 1/2 ma, we can set it equal to that tension force. So we have 1/2 ma equals mg minus ma. So if we put the ma on the other side, it's going to be 1/2 ma plus 1 ma is going to be 3/2 ma, and that's going to equal mg. We can cancel out the m's, and we would get acceleration equals 2/3 g. Okay, for C, find the tension force in the rope. Well, we have two equations that we could use for tension force, this one and this one. I think this one down here would probably be a little easier. Let's do it up here. So we have tension force equals 1/2 ma. So substituting in for the acceleration, we would put 2/3 g. So 1/2 times 2/3 is going to be 2/6 mg, or tension force is 1/3 mg. Or another way of saying it is mg over 3.